Take care. Yeah. So let's start with the things, guys. So, wow. So that is why I was confused, man. Like, why this? I see two people same in the same meeting. Wow. So here, if you see properly, everyone. So here you can see the Arduino. Okay, as I told you about the Arduino, we have GPIO pins, like in any microcontroller that we are working on. So we have GPIO pins and all. So that particularly GPIO pins are what do you say? Separated in two ways. That is called digital pin and analog pins. If you see properly here, if I just told you about the digital pin, I think, and analog pin. So if you see, there is something more here. Okay, like in the digital pin, there is a sine wave thing. If you see in the 11, pin number 11, pin number 10, pin number 9, 6, 5, 3. So these are the PWM pins that we have, like pulse width modulation pin. Okay, so this is the pin that we can use as a analog pin also. Okay, like it's also having a value more than zero, more than two. Okay, but see in digital what happens? We have two values, zero and one. So, but using PWM signal, what happens? We can get a value from zero, like 0.1, 0.2, like that. Okay, so we can get the value. Okay, because it's a PWM signal that we are getting. So it's like it's a dynamic value. It's not a constant value you will be getting. Okay, it's a dynamic value. So you can change the value according to that. Okay, generally PWM signals are used for servo motors. Okay, servo motors and are to control the speed of the motor. Did you got it?
Yes.
Perfect. Any question till now? I think I haven't explained this part, right? And also, if you see properly here, we have some communication protocol that we use to communicate with the what is it? This Arduinos. So if you see properly here on this part, we have here. This is the chip. These are the chip that is included for your what do you say uploading the code thing. Okay, like you connect your USB here to upload the code to this particular board. Okay, so by how you can connect what do you say communicate with this port to this particular chip, you will be using this chip that is called. So in Arduino, what happens if you buy a original Arduino or a copy version also, you will be getting a chip that is called as Atmel. Okay, and also, if you buy a copy version or second copy, so what happens? This chip will be like different. Okay, so the particular name of the chip will be like CP2102, or what do you say? We can say that CS340. So these are the cheap. What is it? Chips are there. What do you say? It's very cheaper than this particular chip. Okay, so suppose this board is costing around 1600. Okay, so if we just put the different chip here, so what happens? The cost of this board will be becoming like less, like 800, 700, or 600. Okay. So if you buy CS340 Arduino board, okay, CS340 I'm talking about. So you will be getting that particular Arduino in a cost of 300. So like, are you understanding? From 1600 to 300, how it is reducing? The work is the same, okay? The pins that you will be getting here will be the same. The working will be the same. Only the difference between your particular chip Arduino and this Arduino is only this square shape that you are seeing right now. This is a black one. I hope you are understanding.
Yes.
So that is the thing you have to remember. Okay. So if I just show you how what type of things you can see here, let me show you. One second. Huh?
Sir.
Yeah, sir.
Sir, what difference, sir? If we use different chips, what is the difference between, sir? Like, what makes this difference? Like, you
The
are
cost,
using different chips.
the cost,
Only,
costing, costing. Yeah,
only
cost.
cost.
Yeah, only cost. So if you see, let me
Okay.
show you the board. Let me show you the thing. The working is same. Okay, the working of the chips are very same. Okay, it doesn't differ anything. If I just show you 341, let me show you. So this is the chip that is a version of SMD part. So it's a, if you see the price, you see the pricing 300 to 85 rupees. Okay, so these are the chips that I'm talking about. See, this is the 3 CH340 chip. This is the 3 CH340 chip. Okay, let me show you the Arduino CP2110. This is one of the CP2102. Okay, the cost of this board is 700. Can you see that? Now let me show you the
Yes.
original one. Okay, let me show you the original, which is made in Italy. Milari bola. Uh, Italy. Okay, so it's the original one. That is the imported one. Okay, that is why its cost is too much. If you see, 2000, 2000, like it's almost 3000, 2000. Can you see that? Are you understanding what I'm saying? Because it's the
Yes, sir.
original one. Doesn't matter, okay? Doesn't matter. The working is the same, okay? Only if you see the working is the same and the chip is the different, okay? Like the coding will be the same. So you can use this type of what do you say, the board, the cheaper version also. You can use it properly. So you will, if you don't damage the board, your board will be what do you say, running the same cycle that it is running over the original board, okay? Generally,
Yes, sir.
what happened, we think that this is the original board. That means like this will be the very original board, so I can just save money by not purchasing again and again. It's not the issue, okay? If you use both the board, what is it, properly, your board will be not damaged, and you can use the board in a what is it, 10 years, 20 years, whatever the according to they are using. Okay, electronic doesn't like see, every time what happens, this board can be have a life cycle of recommended life cycle up to 5 years. Okay, 5 to 10 years in between that. So like people are using this board from the age of their particular decade. Okay, because they are just keeping it and they are not that much using it, and they are using only one time. Like for example, you just uploaded the code, then it is fine. After uploading, what you're doing, you're just using the board directly. So what happens whenever you upload the board, you are just decreasing the cycle of the Arduino. Okay. So like that means you are researching something, and that particular research will damage the board as well, because they will be doing the connection, and in some of the cases, how much you are smart, you will be doing the connection wrong. Okay. It can be a silly mistake. It can be what happened. Suppose you were doing something, but what happened, you just didn't pay attention to that particular part. So that can be a very what do you say, uh, far issue that can be not solved. Okay, so it can be damaged. So it's not like that. If you're smart, you will be saving it. So don't buy the board of that much original one. Okay, it's not worth it. Okay, the who buy this board, like company used to buy this board for their research work. Okay, they usually people buy the cheaper version, like this one, 700 board, or maybe this one, the smallest was a 300 board. So yeah, that is the thing you can do. I hope you're understanding.
Yes, sir. Yes.
Okay, okay. So yeah, uh, done for that. I think nothing is remaining. This shape is done. Okay. Also, if you see properly here, there is something here. If you see this IC, the small one. Okay. What does it mean? This IC is used to what is it? Decrease the voltage. Okay. Suppose you are giving here 9 volt, 12 volt, or something like 20 volt and all. Okay. Suppose you are giving that much voltage. So what it can do? It can decrease. It can step down your voltage to 3.3 volt. So if you see properly here in the board section, we have here 3.3 volt also, 5 volt also. So how it is converting? It is converting because of this IC. Okay, this is called 117 IC. If you search LM117, so we'll get this IC on the internet. Okay, so you can buy it also. It just generally costs 1 rupee. Okay, if you buy in bulk, it will be costing 50 paisa, something like that. Okay, yeah. So that is the thing you have to remember. And also, yeah, this is the DC supply that we can put the input. And also we have one more input that we can give. This is called V input. Okay. But so generally V input is known as raw voltage. Okay. What the V input known as raw voltage? That means the it can what is it? The voltage that we give here, it's very what is it? Dynamic. Okay, it is changing, like it's not constant voltage you will be getting. Okay, suppose you are getting here 5 volts, so you will not get a 5 volt. You can just get 0 volt also. You can also get 1 volt, 1.2 volt, 3.3 volt, like anything. Okay, anything you can get. That is why it is called as a raw voltage. Okay, I hope you're understanding. And here we have the reset button. Yeah, That's it. Any question till now, guys?
No, sir.
So let's do the today's project. A small project we're gonna do. I'm gonna teach you something about the coding part. Okay. So as you are from the IoT batch, okay, guys. So what I will do, see, the for maintaining the class as for the IoT thing, what I will do, we'll be doing some of the project till fifth of the session or sixth of the session, and after that we will be moving forward with the IoT. So we'll be doing some IoT projects. So you will not like what I say. The Abdullah and also others also who have taken the course will not feel a bit same for the both the courses. Okay, because see both the courses are different. Actually, what happens? The IoT and the robotics and the embedded system. What happened between them? Like some of the concepts are the same. Okay, so we need to what you say start with that particular concept. Suppose you are not knowing about anything about Arduino, so you will not get anything. Are you understanding? You will not able to understand. So that is the thing you have to know. I hope you're understanding, guys.
Yes.
So let me show you. So let's do the today LED blinking, okay? And also I will be giving you assignment to do that also. So let me know if you don't understand the assignment. Let's finish this thing, okay? Let me delete this part. Delete this part. Then let's also delete the coding part. Okay, done. So as he, okay, I will just delete this also. So you will understand. Yeah. So here, and whenever you just open a project, you can just click on here. They drag this Arduino ID, sorry, Uno here, okay, and just a small project we're gonna do that is LED blinking, okay. So I'm gonna teach you how to write a code for LED blinking, okay. So we're not gonna copy paste the code, okay. We're gonna directly write it. For now, let's remove this register here, and let's connect this LED here, okay. Now, as I told you, now just tell me, LED is a digital component or analog component? Hello guys, are you there? Hello, anyone? Hello, Shashirad.
It's digital.
It's a digital component or
Digital.
okay, noted. So it's a digital component, right? So now just tell me, uh, in which pin we're gonna connect it to the digital pin or to the analog pin?
Digital, sir.
Perfect. So yeah,
Both of
as you
them.
can see, here, this one of the pin is called as anode, and the one of the pin is called as cathode. Okay, so this pin are known as this anode is known as positive, and the cathode is known as negative. Okay, so always the negative pin will be going to the ground. Okay, so in Arduino we have three grounds. Okay, if you see here, G and D is called as a ground. So this is the ground here. Okay, and wait for it, and this is the ground here. So you can connect any of the ground. Okay, negative pin can be connected any of the ground. It is not mandatory that I have connected to that particular ground, so you can't connect it. You can connect to here also, here also. Okay, so that is the thing you have to remember. Done. After that, also connect this anode to the one of the digital pin. It can be connected to any of them. Okay, whatever you write the code for, you have to connect on that. For example, suppose in the code I'm gonna write it down to the 10 part. I'll just connect it to the 10 pin number 10. Okay, and just remember in which pin you have connected. Okay, then for that, just arrange the wire like double clicking on it. You can just make a point. After that, double click on it again, and then connect it to the black. Purple. Done. Okay. So I just what do you say? Kept this register as the like here. Okay. So just let's not what do you say? I will explain you why I've kept here, why I'm not connected here. So like you will understand. Don't worry about it. So the connection is done. Okay. Only we have to do two connection for the LED part. After doing the connection, we can just go to the code section here. There will be blocks. Just convert this thing to the text coding. Okay. If you see here, there will be a predefined codes. Okay, this is a LED blinking predefined codes will be there. Just remove the code. Okay, you can remove all the thing. Okay, if you remove it, the void setup and void loop. Okay, generally don't remove that, but for your understanding, I will be removing the void setup and void loop also. Okay, this will be given as a predefined for you. Okay, whenever you will be opening your Arduino ID, let me show you. Okay, this will be there. Okay, this will be there. Let me show you how it is there. If you open an Arduino ID, so yeah, if you see properly here, if you click on the new file, new sketch, so see, void setup and void loop, it's already there. So this is a predefined thing that you will be getting. Then also I will be just deleting that and I will be, okay, wait. Yeah, I will be just deleting that and I will be recreating that. Okay. So let's write the code for it. Okay. So for understanding purpose, what I do, okay, generally for any microcontroller that I'm working on, it can be microcontroller, it can be microprocessor, it can be Raspberry Pi, anything. Okay. So what I consider by programming it, like I consider it like it's a very a small child. Okay. Like anything, because we have to explain it again and again for that. So what I'm gonna do, I'm gonna explain the Arduino that like we have some pins, okay, here. So we're gonna use some command to let Arduino know that like something is connected to the pin number, like whatever the pin number we have connected. For example, if you see as pin number 10, there is a connection, okay, there is a connection we have done. Don't consider this connection because this is a ground connection, okay. Generally, we don't consider it because see we have to connect it, but don't consider it, okay. Only the connection that you have to consider is the positive one that is connected to the digital, or either it is connected to the analog, or either it's connected to the any of the other pin other than the ground and VCC. Okay, ground and VCC means power pin. Okay, this pin. Okay, so you don't have to consider that. Just consider this one. So as a like Arduino should know like which pin is connected to the which of the pin, which sorry component is connected to which of the pin. So we need to like tell the Arduino that there is something connected to your pin number 10. So we're gonna write it down some function that is called hashtag define. Okay, and we're going to name a thing, name the component that we have connected. So it's not like you have to name it properly. Okay, it's a variable, so you can just name anything. For example, let's suppose I'm, so you can just like suppose for my purpose, for my understanding purpose, I will be just writing down LED. Okay, you can also write your name. Suppose I'm writing my name, so I can write the name here also. But remember, this this thing will be using in every statement here. Okay, whenever you write something, whenever you define something, you will be using throughout the code. Okay, so I am defining LED. Okay, or suppose I'm this is a red LED, right? So I will be defining red LED. Okay, red LED defined. Now in which pin it is connected? Pin number 10. Done. The define part is done. Now I have told that to the Arduino, I have connected something to your pin number 10. Okay. And that particular name of that variable is red LED. Are you getting me, guys? Did you understand?
Yes, sir.
Perfect. Now what we can do, we can write some function, okay, in which we gonna explain the Arduino that because see Arduino what happens, Arduino take the input also and gives the output also because we have GPIO pins, okay. So for that particular purpose, what we're gonna do, we're gonna tell Arduino that. Okay, yeah. So we're gonna tell the Arduino that like this thing it will be taking input or output. Okay. Now just tell me, LED will be taking input or output. See, in LED will be giving the input to the Arduino or it will be taking the output from the Arduino. Tell me that.
Output, sir. Taking output.
Perfect, perfect. So what we're gonna do first, we're gonna write the function name as the function name was setup, void setup, and then the curly bracket we're gonna write it down, and everything that we're gonna write it in the void setup part. Okay, this void setup is also known as what is the initialization setup. Okay, so we initialize all the thing here. Okay, so in that what we're gonna write, we're gonna write pin mode. Okay, after pin mode, we're gonna write it down the name of the LED, comma. Okay, LED comma, and that in that we're gonna write it down as output. I hope you understand. Okay, I have told you whatever the okay. So sorry. You have given the name as red LED, right? So you have to take the name as red LED. Are you understanding, guys? Pin mode is a function that we have to define it for input and output. Okay, and we have to name the variable in which we have to select it as an input or output. We have named this variable as a red LED. That is why we are considering as a red LED. Are you getting me?
Yes, sir.
Okay. So yeah, for that, after that, what we want the function to be done in like what do you say, in regular manner. Okay, like it should be doing and doing. Okay, continuously it should be doing. So what we're gonna do, we're gonna write down the function that is called void loop. Okay, and in the curly bracket, we're gonna write it down what we want exactly. Now you have to remember four commands. Okay, just four command you have to remember. That is digital write. Okay, and digital read, and that is digital. Sorry, not digital. Analog write, analog read. So as you can see, we have two things, right? Analog or digital. So that is why we have four commands. Like either it will be writing, either it will be reading. If it is having a sensor, we will be reading the value. If it is having a component that we have to write something like, for example, we have to control that particular part. So we're gonna write the function. Are you understanding, guys? So now just tell me for LED what you're gonna use. You're gonna use analog read or analog write or digital read or digital write. Tell me that.
Digital, right?
What you're saying?
Digital, right?
Digital write. What is the reason why we are using digital write?
Like, it's taking output, na, sir. So we using and
So
it's
like,
taking digital output.
yeah, perfect, perfect. So what we are doing exactly, this is the digital component. So that is why we are taking digital command. Now in digital command, what we have two commands we have, digital write or digital read. Okay. So what command we gonna use? Like see, it's not giving any value. Okay. So it's not gonna read any value from the LED. So that means that only one thing that is remaining, that is called digital write. That means we can control the LED. For controlling the LED, that means it is the output thing. So that means we can write it. So these are digital component. That is why will be using as a digital write command. Okay. So here we have the digital write. So we're gonna write digital write, and the same we're gonna write the name of the LED, red LED, comma. So what do we want? We want the LED to be on, right? So you can use either one or either high. Okay, either one or either high for switching on the LED. Okay, and let's give a delay. Let's give a delay. So like suppose you want to give a delay of 1 second. So you have to write it down 1000. Generally in ID, what happens? You have to give in millisecond. Okay, so this will be considered as a millisecond. So whenever there is a 1000 millisecond, that means it is 1 second. I hope you're understanding. The same thing will be going again. Digital, right? Now in this time, what we're gonna do? We're gonna low the command. Low. Okay. After that, you're gonna give a delay of 1 second. Done. I hope you understand, guys. Did you understand?
Yes, sir.
Okay. So let's start with the simulation. Let's see, is it working? Wow. Can you see that? Is it working? Guys, are you there? If you see properly here, there is something that is a warning sign it is giving. Current through the LED is 51.3 milliampere, while recommended maximum is 20 milliampere. Okay. So the enable lifetime. So it may cause the decrease in lifetime of the LED if we use this much amount of current. So by like we can use the we can just decrease the amount of current by using resistor. Okay, so what you can do, you can just delete this wire and connect direct this LED to the pin number 10 like this. Okay, one of the pin will be connected to the positive and one of the pin will be connected to pin number 10. After that, just click on this resistor and just decrease the amount of ohms. Okay, it's a kilo ohms. Just I will be just using 100 ohm. Okay, 100 ohm will be fine, I think. Let's start with the simulation. Can you see that? Is it showing the warning sign, guys?
No, sir.
That is the use of the resistor. I hope you understand.
Yes.
Now, what I want from you guys, a simple assignment. I need it like a LED. Okay, we need three LEDs here, and we need three resistors. So actually, I need to make a traffic light signal. Okay, okay. Let me yellow and then green. So what I want, it should be working like a traffic light. Okay. So that is the thing I want from you to make it because you know how to do this thing. Okay. So for most of the LED, what you will be doing, you will be connecting the LED same. Okay. This thing also will be going to the ground. Just connect this thing to the ground like this. As I told you, we can connect to the any ground. Okay. So we can connect it here also. Okay, and just change the color of it and just connect this LED to rest of the pin. Okay, after connecting it, just define the pin here again, define the pin mode and define the like sorry use the loop section what you want. Okay, in which section, suppose you want to on this green signal for 5 seconds. Okay, after 5 seconds, this two like whenever the green signal will be on, this two will be off. Okay, and whenever the yellow signal will be on for 2 seconds, this will be off. Okay, so whenever this will be on, this two will be off. Like that, it will be working. Okay, are you getting what I'm saying? I hope.
Yes, sir.
Okay, this is the project. After doing the project, you can just go to the Tinkercad. Okay, after that, what you can do, you can just click on this setting here. There will be a setting here. If you see properly here setting, click on that, click on the properties, just go down, scroll down, there will be a private share link. Okay, just click on share link here and save it. After saving it, just go to here, click on the project and copy the link and you can share me on the WhatsApp. Did you understand?